With your request, the Docker course is here. And this course is all about the Docker basics and how you can get started with the Docker. If you don't know about Docker, this course is for you. If you have knowledge, this is a very nice refreshment. This course is not specifically connected to any specific language like Laravel PHP or Java or Python or Node. Although we are going to use the Node example, but that's not any big deal because you don't have to worry if you don't know about Node. But what are the things we are going to cover in this course? Let's see. So first, we will talk about what is Docker, which is extremely important if you don't know what Docker is. Then how you can install the Docker in your operating system, then what Docker images are, and the images command. Then we will talk about the containers and obviously the container commands. So after that, we will talk about what are the difference between images and the containers. Then we will talk about how we can run the container interactively. That means running the container and doing something inside the container from your terminal. Then we will see how we can share the port of container and the localhost to run the Nginx in our system directly from the container. Then we will see some detach mode thing. Then after that, we will talk about the container versus VMs, the virtual machines. After that, we will see how we can share the volume. That means the specific directory or folder of container to the folder or directory of your local machine. How we can share that. Then we will talk about how we can create a new fresh image using the Dockerfile. Yes, we will create our own image. Then we will run the Nginx in daemon mode, without daemon mode, and see how we can run the container, always keep on running with the Nginx on that. After that, we will create the Docker volume. It's not the sharing of the directories, it's creating the specific Docker volume. So this is really important for you. After that, we will also see how we can work with the network, why we need network and what is the use of network. Then finally, we will going to use the real application, a Node application, which is very old, the Node 12 application. And this is the real use case. We will see how and where Docker is useful for the older things, for any version. This is very important. After that, we will see how we can persist the SQLite database using the shared volume thing. And finally, we will see how we can connect the Node application with the Mysql database. So for that, we need to understand about the Mysql image, and then we will really run multiple container. For one is for Node and one is for Mysql. And after that, since we have two container, we need to connect them. Containers are isolated, but we need to connect them. So we will connect through the network and we will do a lot of things, but doing everything manually is not a good thing. Just like we have the Docker file for creating the image, we will use the Docker compose file to create the containers. After that, we will see how we can use the Docker file to create multiple containers, volume, sharing port, and each and everything just with one command, which is Docker compose up. So this is all about the Docker thing, and now let's start the Docker course. Let's start the journey of Docker. So first thing comes in our mind is, what is Docker? Before explaining you to what is Docker, let me tell you a very nice story. So suppose we have these two ships, and these two ships are hired by two amazing companies, Apple and Amazon. Now, suppose Amazon want to send or ship all their Echo Dot, the Alexa, from US to India. At the same time, Apple also want to ship all their MacBook Air from US to India. So since they have hired these two ships, what they can do, they can put their products on these two different ships, and then these two ships will move from US to India at the same time. But you can see that this ship, both of these ships have a lot of empty spaces. So this is a wastage of resources. Resources like obviously the ship, the space, the diesel, and everything related to these shipments. So what is a good idea? So both company can combine and hire this ship, which is a single ship, but their products are shipped at the same time from US to India in a single ship. This is more efficient. But doing this is again not a good idea because these are not isolated. That means anybody can touch the Apple MacBook Air or Amazon Alexa. They can damage it, and something bad can happen to these two products. So what they can do, what these company can do, they can actually use a container thing. So what this container will do? Container is actually a isolated environment or isolated thing which is not going to interact with each other. In that way, both of the product, if we put these products inside this container, then these products will be secure, safe, and totally isolated from other environment. And after that, we can just put these two container on the single ship and ship that product from US to India. Isn't it a good story? But this story is actually the concept behind Docker and containerization of the applications. So basically, when you put a lot of container in a single environment or single host, here we have ship in this case, we call it docking, and from here the word comes Docker. So Docker is an open source platform for developing, shipping, and running the application. So isn't it easy? So Docker enables you to separate your application from your infrastructure. Infrastructure means the hardware you are using, the operating system you are having, and how it do with the container thing. So Docker is a platform independent thing. What that means? It doesn't care if you are using Windows, Mac OS, or Linux. You don't have to worry about that because containerization by using the Docker is not dependent on the platform. That means if you have the Docker installed on any of the platform, it behaves exactly same whether you are using Windows, Linux, or Mac OS. What you do, what Docker will do, it just containerize your application. And you got the concept of containerization, means isolating things and it doesn't use much resources, just use the resources that the product need or the application need. So Docker provides the ability to package and run the application in an isolated environment called container. As we already know that this is the container job, to isolate and pack all these products, all the application in an isolated environment. So each container, if you talk about in terms of the application, the web apps thing, each container can have their own version of Node, MySQL, Java, etc. and run different application on same infrastructure. Infrastructure, just like we saw on the same ship, we had the Amazon Alexa and the Apple MacBook Air. Both are different, both need different kind of resources, but on same infrastructure, same host. So for our application, if we have a single server, we can install Docker, which is going to use container or which containerize your application. So suppose application 1 need Node version 15, application 2 need Node version 18, and both will be on separate container, no interaction, both are isolated but can run on same host. So this is the introduction of Docker, what Docker is, how it uses, and how it is working with the container thing. Let's continue by installing Docker in our application, and then after we understand what is container. Now let's see how we can install the Docker in our system. So first, go to Google and type Docker, just the Docker thing. You get this website for docker.com, which is Docker home. And here you can go to the install Docker desktop, or if you go directly to the docker.com, and then you can go the product, and then we have Docker desktop here, which is this one. So let's click on the Docker desktop, and here we are. Since I'm on the MacBook, and MacBook with the Apple chip, not the Intel one, so you can choose the version according to your system. If you are on Windows, then you need to click here. You need to directly click on this Windows, or if you are on Linux, you can directly click here, and the rest of the process is exactly same. So just click on this. So this is going to download the Docker installation thing in your system. So once this is done, just click here, or you can directly open, drag the Docker into your application folder, and that's done. Once you are done with this, and you can open the Spotlight, you can search for Docker, and this is exactly same for Windows and Linux. You can just search for Docker, and Docker application will be there. So you can open it, and this looks something like this. It's opening, and we get this one. Docker is starting. So while this is starting, if you have successfully installed the Docker in your system, then you can go to the terminal and then write Docker version. You will find the Docker version right here. Or if you say Docker, just the Docker thing, and you will get all the commands which are related to the Docker in your system right here, right now. And Docker UI or the Docker desktop looks something like this, where you can have all the images, volumes, dev environment, containers, everything looks here. You can have some setting if you want. If you don't want this to restart on your Windows or system starting, then you can do that, like start desktop when you log in. I don't want that, and some of the other resources you can manage. So that's the simple thing. And what is this? It's a troubleshooting. We don't have to care about that, and you can just close it and back here. Cool. So this is the way you can install the Docker. It's very, very easy, and make sure your terminal or your command prompt or whatever you are using for writing the commands must have this thing, which is like Docker version or running the Docker command. Cool. Now let's move to the next topic in Docker. Let's understand the concept of images. Before going into the container thing, it's extremely important to know what images is and how they can build, they can use, and where they live. So Docker images is made up of collection of files that bundle together all the essential things such as installation, application code, the dependencies. So basically, the Docker image is a read-only template. Using these template, we create the container, or Docker create the container. So think about images as the instructions to create the container, or simply we know that container is an isolated environment where we have the dedicated version of every other resources. So the image tells to the Docker that what the image is, where that image is available, how to pull it, how to connect all these resources inside the container. So this way the image is a read-only template. So why it's read-only? Because you cannot change once the image is created. If you really want to change, you need to create the new version for your image. Obviously, if you are using a MySQL image, if you are using Ubuntu image, that's a read-only. You cannot change. The owner of that image can upgrade the version. So exactly, they cannot change, they can update that versioning. Okay, so we get that image is a template. Using that template, we create the containers. But the point is where these images live, where we can find that images. So image lives in a repository. So you know about the GitHub, the GitLab, Bitbucket, where we host our code. where we put our code into a repository. Now, similar to that concept, if we want to find the images, if you want to put our images somewhere, there is a repository thing. So where that repository is, for the code we have a GitHub. So for Docker we have a Docker Hub. So Docker Hub is a hosted repository service provided by Docker, the company Docker. Okay, so this Docker Hub is provided by the Docker company for finding and sharing images with your team. So yes, you can put your images, but there are a lot of open source images available inside this Docker Hub. So similar to this Docker Hub, if you don't want to use it, if you are not trusting this Docker, then you can use the AWS ECR, Elastic Container Registry, where you can put all your images and that will be isolated, secure, and nobody can use it until the access is there. So let's go to the Docker Hub. So if we go here, this is the Docker Hub. So the website is hub.docker.com. See this one? I can zoom it for you. hub.docker.com is the website, and then you can search for any kind of image. So right now you can search for Ubuntu. So we have suggestion. Let's click here and we get this Docker official image. So this tag is saying that this is an official image of Ubuntu. Similarly, if we search for MySQL, click here. Again, Docker official image tag is there, which is ensuring that this image is really created by the MySQL team. So it's an official image. Now, this is an image and this lives here. So you can see that we have a lot of tag and versioning thing available here, and you can have the reviews. You can see like what is MySQL and something related to that image, how you can use it. Everything is written here, and it's a great place, and we will going to spend a lot of time in this Docker Hub. And you can see it's all available free. It's an open source thing, so you can use this command to see how we can pull the image. Just like we pull the code from GitHub, similar to that, we need to pull our image or any Docker Hub images. Okay, so this is the right thing. Let's go to the slides and see what next we have. So now, what are image layers? So the image, as I told you, is a collection of different essential things. Now, each essential things, it could be the installation code, it could be some, let's see, it could be some dependency, it could be some installation instructions. Each one can have their own image layer. So a Docker image consists of different layers of image layer. So each of these files that make up a Docker image is called a layer, and every layer is dedicated to some important things. So this is the real concept behind image and image layers. Now let's go to the terminal and actually see how we can interact, we can play around with the Docker images. To understand about the Docker images, here I'm on the terminal. If you are on Windows, use command prompt or any kind of thing where you can write the commands. So first thing, I'm going to write the Docker. Oh, I need to remember the spelling first, and here I am on the Docker. So since we want to learn about the images, let's just find where on these list of command we have the word image. If I search for image, there is an image which is for management command. Okay, then we have here on the real command we have a build an image from a Dockerfile. So yes, we will going to learn about the Dockerfile in the later episode, but not now. But we got that we can build something with some kind of Dockerfile for an image. Next, where we have now create a new image from containers change. this is an interesting thing. I told you that we can also create our own image, and this is the command which is going to create a new image from containers changes. If we change something in the container, we can create the image. Next is this one, history. Show the history of an image. Some kind of history thing. Okay, we will check that. Next is images. This is a really amazing command, and a lot of time we are going to use this command, which is just going to list all the images we have locally in our computer. So this is extremely important. Next is import content of tarball for create file system images. Skip that. And then we have load image from tar archive. Think about this as a loading image from a zip file. Then we have a pull. Again, a very interesting and very useful command called pull. And pull is just going to pull image or a repository from the registry. So we know the repository is Docker Hub. If we want to pull from any image from there, we are going to use the pull command. Similar to that, if we want to push new image or new tag, yep, push is there. Next, we have RMI, remove one or more images. And RMI means remove for RM, I for image. So RMI, remove image. Next is the save one or more tar file. Search for searching for Docker Hub images. We will use this command right here after searching this, and then tag in the image, and that's it. Cool. So we understand that a lot of commands are there, and the first command I want to explain you related to the images is docker search. And let's search for the MySQL image. And since we know that this search command is going to search image on the Docker Hub about the term we have used. So it says the name, description, stars, official or not. So related to MySQL, we got a lot of images, but the important one and at the top is this one called MySQL. MySQL is widely used, open source, blah blah blah, but it has this many stars. This is the one we really want to use. And if you want to see this in Docker Hub, you can just go to the Docker Hub and see I have this MySQL image which is having exact same description which we have here like this. Okay, and how many stars? 1 2 6 8 9. So 1 2 6 8 9. How I can check the stars? Somewhere I should check, but I can't find it here. No issue. We will think about that later. But since we know that this is the very nice command to search the images, let's now pull this MySQL image. And we know that to pull, we have this pull command. Pull command is pull an image from a repository. Let's do this. So I'm here and I'm going to say docker pull MySQL. And when we do this, let's see what's going to happen. And this command is exactly available on this Docker Hub, and it says you need to run this command to have this image from the Docker Hub into your system locally. Okay, let's run this command. If I hit enter, first it says using default tag. What that mean? That means getting the latest version. Now it says the latest, pulling from library /MySQL. No matching manifest for Linux, something something. What happened here? Let's see. Everything is fine. I don't know whether we really have the image or not. So remember, we have one command called docker images. Using this command, we can see how many images we have locally in our system. So right now I have two images. One is docker getting started and another is Ubuntu. Okay, but the problem is we didn't get that MySQL. We will see how we can pull this image later on, but let's first see how we can remove this Ubuntu and then once again get this Ubuntu. So we know there is a command called docker rmi, remove image. But how we can tell which image we want to remove? So yes, we know that we have a Ubuntu image and we named it, and it says that okay, untagged, we found Ubuntu latest, then we are deleting these two. So these are the layers of the image, so it's now deleted. So now if I search, if I run this command docker images, you can see the Ubuntu image is not available here. Next is you can also remove the image by this image ID, which is the real thing. So just copy this and say docker remove image rmi, the ID of the image, and hit enter. It says that conflict unable to delete by stopping container. So what we can do, we can just remove this image by using this force flag, which is going to force removing this image, and now it's removed. So we know that how we can remove a normal image, how we can remove if there is an issue with the image, we can use a force. And now if I search for docker images, you can see I don't have any image in my system locally. This time I'm going to get the Ubuntu. So I say docker pull Ubuntu. But before that, do you want to search it? Let's search. So it's searching and we get a lot of Ubuntu, but this is the one we are interested. So just get back like here. And you can see first it says that, okay, I'm going to use the latest tag, which is the default tag. Then it says that, okay, latest pulling from the library, and very easily we can see it's downloaded or pulled completed. Then it says downloaded newer image for Ubuntu latest, and everything is there. This means this image will be available in our system. So if I say docker images, again you can see Ubuntu image is there with the latest tag, with the new image ID. It's a fresh image ID, and and this image is created 5 weeks ago, and the total size is this one. Now you may be thinking about, is this Ubuntu only 70 MB? No, it's just the essential thing in Ubuntu needed for running any application. So that's why the size is absolutely small, and this is the reason the Docker is so famous. And now let's understand some more command related to images, obviously. So I will say docker images, and then I'm going to get the help. So if I get the help by saying -h, actually docker image, not the images, then we get some specific image related command. So we have docker image build from Dockerfile, the history, import, inspect, load, ls listing the images is exactly same like docker images, prune, remove unused images, push, pull, remove, we know removing one or more image, and save and tag. So everything we did with the docker command, like docker remove image, docker images, we can do everything with the docker image command. So docker image, and then we can say ls, it's going to list the command. If I say docker image remove, we need to give the image name, image tag or name to remove that. So this is the real thing, but let's see. If I say docker ls, we get this image. And now I want to say image, docker image, and give me the history for this ID. And you can see we have this. This is the way you can get the history for image and all other image related command. Now let's solve our problem. And this is not our problem. This is just my problem for pulling the MySQL. And if you only have the M1 chip, then only you will get this kind of error. Otherwise, you will not going to get this error. So what happened here, it says that there is no image for MySQL available for the Linux ARM processor. Now we need to tell to the Docker that, hey, do not get this ARM related MySQL image, get me the normal image. So how we can tell to the Docker? So we just say docker pull, but this time I will say platform is 86 underscore 64 and then get me the MySQL. And now it's going to get the image for not for the ARM but for the normal processor, and this is how we can get, and you can see all the layers for the image is available and downloaded one by one, and very soon everything will be in our system. So it's a big image, yes, that's why it's taking little time, and since it's downloaded we can just check for images, and this time we have the MySQL image also, and this is really a big thing, 524 MB. But since it was on the layers, it was downloaded very quickly, and at last we can just say docker remove rmi, and you can get the ID or directly write the name, and it's done. Every layer is deleted. That means we get rid of the MySQL. Cool. So finally, let's now move to container, because we know we have the image, how we can interact with the images, where the image live, but how we can create the container using this image, because image is a template for creating the containers. Talking about the container is really important thing in Docker world. Why? Because everything is containerization of the application. We understand about the image, and we know that image is a template for creating the container. But what is a container? Let's understand. We know the analogy of shipping, the ship, the container, this kind of container, with the Docker and the application containerization. So containers in general sense is an isolated environment where we have a lot of container, but each container is isolated, secured from another one, and all the container are on the same platform, same host, or in the real world, same ship. So that's why the containerization is really amazing concept. So if we talk about the Docker, how the Docker and the application thing work. Generally, we have a infrastructure in terms of the hardware you have and the server maybe you have. Then over that, we install a operating system. It could be Linux, Windows, or Mac OS. Inside that operating system, we install the Docker. The Docker desktop is really amazing, or maybe the Docker client, you understand it like this. So what Docker will do? When you run any image, then Docker will going to create a container. Container like having an application A inside that, then another container where we have application B, and similar C, D, E, F. Now, suppose application A need PHP 5, application B need PHP 8, application C need Java 18, and application D need Java, let's say 12. Now, each and every application requires different version of dependencies, different kind of dependencies. One is a PHP, one is a Java, totally different things, but running on a same host, same infrastructure, same operating system, but isolated, secured, because the container A doesn't interact with container B, and so on. So each and every application is running isolatedly, and that is why it is called containerized application. Let's understand more about the containers. So the isolation and security allow you to run many containers simultaneously on the same host. And that's true, because if nothing is interacting, we can safely manage and run different container on the same host. Containers are lightweight and contains everything you need to run the application. So now suppose you want MySQL, then in one container you need a MySQL. In another container you may need a MongoDB, and yes, you can have that. So you do not rely on what is currently installed on the host. So suppose in my laptop the PHP version is 8, but my application need PHP version 5. It doesn't matter what you have on the system, it totally depends upon what you have inside the container. Next is you can easily share container while you work, and be sure that everyone you share with the get will get same container that work on the same way. Since Docker is platform independent, if I have created a container with the dependencies of MySQL, Node and Java, and then I can share that container with some other people by using the image, because basically the image is everything. So we share the container with my friend, and when my friend use that container, it's going to be same exactly, because it's isolated thing. And this is why the container is so great. You may have heard about the phrase like, this is working on my computer but not on server. And that happened because you are using Windows and in the server you are using Ubuntu. So that's clashing the things. But if you have the Docker, the container thing, no issue will be there because everything is on the same platform. Okay, so let's see the container in action. To understand how the container is created, how we can interact with the container, let's write Docker here on our terminal. And we get a lot of command, and once again, as we always do, search for container, and then we will see we have a lot of command related to container. So there's attach, then commit, copy, create, difference, execute, export, kill, and log, pause, port, ps. This is the really good one for listing of the container. Then rename, restart and remove for removing the container. Then running a container and start, stop, a lot of other things. So first thing is really good, which is saying that docker ps. If we execute this command, we can see we are getting nothing, just the title. So this means Docker says that, hey, you do not have any of the running containers. All the container, if you have either stopped or there is no container. So how we can check that even we have the stopped container? For this, you can write the docker ps -a for the all. And yes, you can see we have some kind of Ubuntu container which is having a status of exited. That means it's not running. And what we ran inside that, we ran this command called bash. So now let's clean up this, and then we will see how we can create the container. So for now, docker remove, and removing with the name. So see, the name is intelligent something something. So let's copy that and paste it. So rm command is going to remove the container. You know, rmi command. So rmi command was for removing the image, but this one is removing the container. So we get the name back. This means we are successfully done. So this means if I check, there is no container even stopped, even exited. Then question comes how we can create the container or how we can run the container. So to do that, what we can do, we can simply say docker and then search for create, and you can see we have a create command which is going to create new container. But before that, how we can use this create command? If you have a doubt, then you just say help, and this help is going to say that what you have to do, docker create and then the image name. We already have the image, so let's search for image. And if we search for images, docker images, then we have a Ubuntu image. Let's use this Ubuntu image. Docker create Ubuntu. This time I'm going to use this Ubuntu image to create a container. Let's run it, and in return we get a long hash ID. This is the ID of our container. So yes, if we check, oops, we didn't get anything. But what if we say all? Right, so you can see this is the exact ID for the container, same is here, and the name, the image used is Ubuntu, and the command we ran is bash. But we didn't ran anything, we didn't tell anything, but it's a default thing. So how much time it was created? 15 seconds ago, and it's just created. And then we have the name. So how we can see that where is the container and what we can do with the container? Before moving to that thing, it's just say created, but we know that this is not a running thing. This one is not running. So what we can do, we can now use another command called once again search and we have a start. This start says start or one or more stopped container. So we really have a container which is it's just created like here, and it's stopped because we don't have any container inside the running container. So we can say docker, and first we need to get that name, get the name docker start, and this is the name of the container. Okay, this is done, and let's run once again. Once again we are not getting it, but it's still saying that hey, you have exited from it. What that exited means, so previously we had the created with everything same, we just have the status of exited. So first time we have just created the container, we have never used that container. Next, when we said that hey, start this container, then we ran this bash command inside of the container, and then since this bash command is a one-line process, it just did the job and exited on that. This is really good thing. Since we have the container, let's remove this and let's understand how we can create a container where we can do something which is not just exited, which will run for long time. So first I say hey docker, remove this one, and if I say docker psa all, no container is running. Now if we see that images thing, yes, we have the Ubuntu image in our local system. If we search for any container, we don't have any container. That's good. Now let's remove the image also. So let's say rmi for Ubuntu. Everything is done, deleted. So now we don't have any image, we don't have any running container, everything is clean. Now let's use a command called run. So let's get the help for run command, and this run command is going to run a command in a container. This is an interesting thing because when we say hey docker run Ubuntu, now we don't have any image for Ubuntu in our local system. We didn't tell that either we want to start or just want to create. We said that run the container, and we don't have the image. So what if I enter it? It says that hey, you are trying to create a container with the Ubuntu image, but Ubuntu image is not locally available. So it's now pulling from the Docker hub. Once it is done, it has actually downloaded the image and also started the container. So let's first see, do we have the image? And yes, we have the Ubuntu image. Now let's see, do we have any container running? Yes, there is a container which is not running, is exited when we ran this command. So docker run command is actually a combination of a docker pull, the imaging pull, then docker create to create the container, and docker start to start the container. 3 commands in one command. So if we have the image, and now this time if we try to run once again docker run Ubuntu, and this time I will say ls, and this command ls command will going to run inside the container just like bash, because this is the default one. If I enter, then you can see we are getting these things: bin, boot, dev, All these things are available inside this Ubuntu, and that's why we have this ls. So this time if we try to run the PSA, now we have another container because we have run 2 times the docker run command using the same image, the Ubuntu image, but created 2 container. One container was running bash and second container was running ls command. And after running, the container was exited. It was not destroyed, it just exited. Cool. So this is the way you can start a container, create a container, and use the image which you have and directly do the 3 command in 1 command. So you can see that if we run it, it's not checking, it's not downloading once again the image because image is already available locally. If we remove the image like this, oops, like this, and it's saying that, hey, you are trying to remove this image, but there is a conflict. So whenever we have a conflict and we are sure that we really want to remove it, use the force flag. So we can use double hyphen with the force and it's deleted. And if I again try to run container by running the docker run Ubuntu, this time we have removed the image, it's going to first check for local, it's not available, then it's going to download from Docker Hub and run the command, and it says that, hey, it's already available because it was maybe available on the cached, so that's why it is there, and ran the container. So one more time, let's quickly check the container thing. So a lot of containers are there. Let's clean up and then we will move to the next video, which is for some amazing thing in container. So remove, but this time I want to remove all the container. So what we can do, we can say ps a for all, and if we say q, we only get the container ID. This is a good command, psaq. So let's copy all this command and I say, hey, docker remove, and then run this command first and then remove everything. If I do this, it says that, okay, I first run this command, so then this will give you all the ID and removing the all container with the ID. So that's why if we say that ps all, cool, we don't have any container. And if we say images, we can remove the image also, rmi ubuntu, and that's deleted because there is no container attached to this image. Everything is clean. Let's move to the next video. We have interacted with the images. We know how to create a container. Let's understand the difference between the images and the containers in Docker. So an image is a read-only template with the instruction for creating a Docker container. We already know things. A container is a runnable instance of image. That's good. We already know these things. So since an image is a template, we can use the same template to create multiple containers. So in this example, you can see a single file with all the dependency and configuration required to run a program, we call it image, can create multiple instance or multiple containers on the same platform. That's good. Next, images. Often an image is based on another image with some additional customization. So it could be possible that you have created your project image and you put it online, like it could be on private repository or Docker Hub for public one, but that project image will include the Ubuntu image, the Mysql image, or the node image. It could be possible. So an image is based on another image. To explain you where this image of image is, let's go to this Mysql, the Docker Hub, and this is the Mysql official image. If you search on if you go on any of these tags and then click on any tag, you will land it to the Dockerfile. And you can see this Dockerfile is using another image, Oracle Linux. This means the image or the MySQL image we are going to use is based upon another image. And this is what this says, that an image is based off another image with some additional customization. But in the container case, a container is a relatively well isolated from other container on its host machine. That's good. Image, you might create your image, or you might only use those created by others and published on the registry. So you can create your own image, or you can just use the image available on the Docker Hub or maybe on your Amazon. Then a container is defined by image as well as any configuration option you provide to it when you create. So when we create the container, we can tell that, hey, when you create the container, you can install something. Not using the image, we can directly install. So if we have a container for Ubuntu, we can go manually inside the container and install MySQL, just like we install MySQL on a normal Ubuntu platform. So this could be possible, and that's why it says that your configuration options provided by you. This is the thing, and this is the difference between the image and the container. Let's now move and understand more of these things, more of the Docker command, and especially the container. Very excited one in the next video. Now remember, in the last video when we interacted with the Docker container related commands, we had created the containers, but every time we create the container, the status was exited. Let's start from once again, and I'm going to remove any image if we have first for any container, and then I just want to say remove image if we can get the images like here and Q. So every image is deleted. There is no image, there is no container. Cool. Now let's run Ubuntu. I'm just running it and let's see what's going to happen. First it says, hey, it's not locally available. Then it's going to pull from the Docker Hub, and then it's going to run the container, create it, and then run it, and everything is good. Now let's say Docker PSA. It says that yes, there is a container, but the container is exited just 5 seconds ago. And what we had done on that, we ran this bash command, but we know we can run some other things. So let's run the ls command inside this Ubuntu. So when I say ls, it's going to create another container, new container, and then run this command, and after that it just exited. Cool. This is good. But once again, if we check for container, we have a 2 container. We can run, or we can restart the container by saying that docker start with the id. So if I say id, once again it's ran but exited as soon as we have created, but we are back on the exited. Now what we can do, another thing. So we are using the run command. If we can get the help for this run command, let's see what's going to happen. There are a lot of flag or the options available for our run command. The one I am interested is this I command called the interactive. Keep stdin open if not attached. Let's see in action. So when I say docker run, but this time I'm going to say, hey, give me the I flag with the Ubuntu. Let's see what's going to happen with bash. It's a default one, but let's use it. Something happening. We cannot see that thing. Although you can see the container is running, this is not stopped. And if we open another terminal and say docker psa, This one which is just have created is still up and running for 14 seconds. It's still running for 22 seconds, and in our case it is looking like a stopped, or not a stopped, it's a freezed. So you can see it's freezed. So this interactive command is really nice, that allow you to keep running the container on that server. But if we press Ctrl C, although it's not doing anything, I have to write the exit. After writing exit, if we can check for container, you can see now it's exited. So we got that there is a command called I, which is really useful for keep the container running. But there is another command. So docker run help once again, and this time I'm going to use the command which is the option which is T for TTL. It's allow you to sudo tty. It's tty, not ttl. So tty simply means allow the virtual terminal in our system. So we are going to once again say, hey docker run with the interactive flag with a tty flag a Ubuntu container. This is really great, and if we run it, we get that root. And here you can see it's simply like we are on a Ubuntu server. So we can say that like ls, we can do the ls, we have all these list of the directories. Then we can say sudo apt get update. We can do that update, although sudo is not available right now. We can do the apt get update. It's exactly Ubuntu server. So you can see it's now doing the updates. And if we want to check, do we have the container running? So we can say, hey, give me the list of all the container, and 3 container is exited, but one is still with the bash command, but up on 38 seconds. You can see this is running. If I say exit, now I have exited from that container. This means if I once again check for availability, you can see it's exited 1 minute ago. So it says that, okay, we have the container, which this one, the latest container, which just 7 seconds ago exited, is going to be restarted. We can restart this container, grab this ID, and then I can say docker start, because it's a stopped container. Remember, the start is only to start one or more stopped container only. So let's start. It has started, but nothing happened. So what happened is like it's running in background, and we have no right to exit, like by typing exit. We cannot do the ls, and we cannot do the apt get install, apt get update, because we lose the interactive thing on the container when we ran it using when we started it using this docker start command. So what we can do next to get back the interactive thing, remember we have this container. So let's just stop this container like this, and it should stop it very quickly, which is not doing this. Let's see what happened. It has actually stopped. Yeah, it's stopped in 10 seconds. Then we can say docker start, but this time I'm going to say interactive flag, because this is very important for us. And now let's run it, and we are back on this, and we can say apt get once again update, like this. So everything is back to the normal thing. So exit, and let's recap what we had done here. We use 2 option or 2 flag in the docker run command. One is I, or you can combine it with it for interactive, and tty with the Ubuntu. And this command allow you to interact with a virtual terminal for the Ubuntu container we are running, and while we are on this virtual container, it feels or it is like Docker container is running, and like this it is always running. When we are here, when we just exit from here, container stopped, and we have stopped the container like this. So a lot of container we have. Let's remove each and every container by using this command, which is really great. And now if we try to see, no container is there. Let's go with the images. Yes, we have image. So docker remove image, all the images removed, no images is available. And cool, I think you get the point that how you can go inside of the container and do some of the amazing thing. Let's see what we have in the next video. Now's the time to learn about another flag of Docker run command. So in the last video, we understand that there is a command called I for making this interactive, for T for virtual terminal, which is TTY, and then we use the run command like here and the image. But if we get the help for this run command, we will see that there is another flag which is for the port. So there should be p flag, and yeah, so publish list, small p is there, publish a container's port to the host. What this means, when we use this p flag, then we can connect the port inside of the Ubuntu server of the container and the real host, the system, the laptop or machine or computer, whatever you call it. So let's see how we can use it and when it is useful. Okay, so we have like this one. Where's that? Yeah, so we have interactive Ubuntu container. So let's run it. It's going to fetch the image once again because we have cleaned everything, and then we will get a interactive Ubuntu in our case. So this is good. But let's now say apt install Nginx. So I think apt get install Nginx. Oh, I first need to update it. So let's say update, and this will take a little time, and it's now updated. So apt get install Nginx, and now you can see it's installing the Nginx. So very quickly it's installing this Nginx, and Nginx is done in our container. Remember, this is inside the container. We are on an interactive flag. I'm going to keep this terminal running and open new terminal, and then I will say docker ps a. This container is still running because we kept this right here. Now what I will do, I will first grab the ID, and then I will say docker inspecting this container, and then we get a lot of things related to the container, but the important one is on the bottom is this one, 172.17.0.2. this is the IP address for this container. Can we directly ping this IP address? Let's go and run it. And it's keep on running and loading because it will never find this. Why? Because it's inside the Docker container. Whatever is happening is the isolated thing, is not going to interact with the host. This is the beauty of the Docker. But this is the problem in our case. So we are going to learn about the port thing. So I'm going to say that, hey Docker, when you run this, so let's just see that this container is still running. So we can just we can do one thing, like we can exit from this container. Now container is stopped. So let's see, it's exited. So now let's first clean everything. So I'm going to remove each and every container we have like this, and this time I'm going to say docker run IT interactive, but with the port of 9000 and port 80, and run the Ubuntu container. So what this command says that, hey, I'm going to create a container using this Ubuntu image using interactive and TTY flag, and I want to use the port, I want to connect the port of 9000 locally, that means localhost colon 9000, to the port of container, the 80 port of container, which is the default port. So if we run it, it says that, hey, 9000 is not available. So I can say that, hey, do you have 9001? It says that yes, no issue, go. So we are inside the running container, and this container is now connected with 9001. So let's quickly say that apt get update and apt get install nginx with a y flag, so we don't have to give any response. While this is installing, let's see docker psa. This time you can see this container is running and it's up, and the important thing is the port is shared, so 9001 on localhost. Let's go on localhost and see 9001. We are not getting any response. Do we have the nginx? Let's say nginx -v. Yes, we have the nginx, but nginx is not yet running. So I need to use the service nginx start. This is the Ubuntu command. If you don't know, don't worry about this. So now it says that starting nginx, and it's okay. That means nginx is now started on this Ubuntu server for the container we are here. So as soon as we reload, you can see we are having this nginx right here right now. But from where this nginx is coming, I can assure you that this is coming from this server or from this container by going into var www html. If I go inside it, we have an index for the default nginx page. I can use the vim to open it, and it says that vim is not available. Do we have nano? Okay, nano is also not available. So what we can do, can we do the apt get install vim? Yes, I can do that. So quickly, vim is there. It's a tool to edit it, and now this time I'm going to say welcome to, instead of nginx I say bitfumes, and I save this file, go back, reload, and welcome to bitfumes. And this is coming from this container, from this Ubuntu server. But as soon as we exit from this server or from this container, we know that the status will going to change. Yes, it says now you have exited. Since the container is not running, you can see that we lose this one. So how we can be sure that even if we close the terminal, the nginx will not going to stop, the container will not going to stop? For that, we will need to learn about another flag on the run command, another option on the run command called detach mode. In our case, whenever we stop the container, the nginx also stopped because nginx is inside the container. Right now we can see we have a single container. So let's remove this container. I thought we didn't have any, but now we don't have any container. So let's create a container using this Ubuntu image and with a detach flag. Now what this detach flag will do, it will run the container in the background. So if we say docker run and get the help, not this one, get the help, you can see we have a d flag here, and d flag says that run container in a background and just print the container ID. So this is going to be useful in our case by using d flag. So we said that, okay, run it and move that in the detached mode. That means it will always keep on running. And yes, so if I say docker ps, you can see, although we are not having any interactive terminal, we are not keeping it running, it's running actually in the background. So it's having a status of up for 3 seconds. If we close the terminal and restart the terminal and go, it says that still, even after 30 seconds, it is still running. So what we can do, we want to say that this 9000 port sharing should have the localhost 9001 should have Nginx running. So to have the Nginx running, we first need to install the Nginx, but we don't have any way to move inside the container or run something inside the container. We have. So once again, go to the Docker list of the command, and here we have a very nice command called exec, which is execute. It says that run a command inside a container. So first we need to get the container ID, which is there, and then we can say docker execute on this container, the container ID. And what we want to do, we want to say, hey, just do the apt get update, and after that apt get, okay, so I think it's not possible, so let's do the one by one. So apt get update first. So this is running inside the container. We don't have to go inside the container using the TTY, the interactive thing. It's running out of here. So in that case, when we ran the container, we didn't need to use the I and T flag because all these things is in the background, so no need for that. Since this is updated, we can run once again, we can execute another command called apt-get install nginx with a Y flag, which is going to very soon complete the installation of nginx inside of the container. That's really great. And finally, we need to say start of the nginx. So service nginx start, and it's done. Everything we are doing is from outside but on inside of the container. So the installation, the upgrade, and the starting of the nginx, everything was happened from outside but inside of the container. So let's reload, and we are back with the nginx. And even if we close the terminal, this is going to always run because the container we have is on detach mode. It's on detach mode, and that's why it will always up. So if we want to stop, we have docker stop, and we can stop it. But before that, we can do one more thing, which is called pause. Okay, it's paused. So you can see now this time it's on keep on loading because the connection, the port connection is detached, it's not active. So we can see the list, it says that, hey, it's up but paused. So now we can once again say that, hey, docker just resume this. I think, do we have the resume? So unpause. Okay, so we have the unpause, and you can see as soon as we did the unpause, we are back with the nginx. So we can stop it, and very soon, since the services are running inside that, it will take a little bit of time to stop the container, and in 5 to 10 seconds, you can see after 10 seconds this is actually stopped. And now if we check for docker containers, like here, the container is there but it is stopped. So since it is stopped, we can go and remove this one. Cool. Let's move to the next topic in Docker. Let's now talk about the underlying technology for the Docker. Docker is written in a Go programming language. It takes the advantage several features of Linux kernel to deliver its functionality. And Docker uses a technology called namespace to provide the isolated workspace called the container. So how Docker will know that this is a container and whatever we're running comes inside the container? So that's why we have a namespace system. So under one namespace, whatever is there is come inside a single container, and that's how it creates the isolation. The namespace provide a layer of isolation, as I said. Nowadays, Docker is not just on the operating system but also available on the data center and on the cloud. Next important thing we want to understand is difference between container and virtual machines. So what are virtual machines? Virtual machines turns one server into multiple server. Because they are using the resources of one server, it's divided, so each virtual machine includes a full copy of operating system. And that's why even if you want or not, it's going to take a lot of GBs of space. That's why virtual machine can be slow to boot because it's sharing the resources. So let's see the difference between the containerized application and application inside a virtual machine. We know in a containerized application, everything is managed by the Docker, and every application is required only the things they need, not less, not more. There is no wastage of resources, there is no wastage of any other thing. But in the virtual machine case, virtual machine is going to have the full operating system. That means it need certain amount of RAM, certain amount of space, and these two are fixed. That means even if your application A need 1 GB of RAM, or let's say 10 GB of space, but if the virtual machine having 3 GB of RAM and 20 GB of space, rest is wasted, because you cannot install another application inside one virtual machine, because that loses the concept of isolation. So that's why it was slow, it was heavy, it was wasting the resources, and virtual machine was not a good idea. So let's move to the Docker thing in the next video. We need to understand how we can actually update the Nginx file, or maybe if we are just connecting our project through the Nginx, how we can update it. So we need to use the volumes, and what are they, how it's going to use, and very important thing, why we need the volume thing. So this is the way we start, or we create a new container through the Ubuntu image. So let's run this one, and very nice, we have this hash ID for our container, and we can use this to install the Nginx inside this, and after that we will be able to run this localhost 9000, and that will be nice. So docker execute, and I can use the initial 2-letter only because there is no conflict with the IDs, so that will be fine. So on this hash ID, I'm just using 2-letter of the ID, and I want to run command of apt-get update first. Once this is done, then we will install the Nginx. So let's see, that's done. Apt-get install Nginx with the Y flag. That's going to be successful very soon. And yes, this is also done. So finally we need to start Nginx as a service. So service Nginx is started, and now Nginx page is active. But what if we want to update the index file of this Nginx page? So we need to go inside of the container, inside of this Ubuntu, and if we what is that, if we run this execute command on the 28 and this one, you will see there is a var directory. So similar to that, I will say give me var www html, and if we do this, we can see we have this index.nginx debian html. Now, how we can update this without going inside of the container? In this case, what we have to do, we have to connect the volume, or simply saying, we have to connect the local directory with the directory of our container. So basically what we need to treat this directory var www.html inside of the container to the directory we have here. So I have created this docker test directory. So if I open the terminal here, this is the full path. Okay, so this is the full path for the directory which I really want to treat as the var www.html directory. Okay, so how we can do that? I can copy this path from here, close this one, and then I can first check the container which is still running, because we have used the detached flag, but I'm going to kill this one. So kill 28 and then docker remove 28. Okay, this time there is no container. So if I see this, no container, but now I'm going to run a new container similar to like with the interactive tty flag, detached mode, connecting the port, but also we use the v flag or v option -v, and after that I will say link or connect this directory with the directory inside of the container which is var www.html. Now this is the thing, when we were connecting to the port, first we write the local port and then we write the port of container. Similar to this, when we want to connect the volume, first we give the path of the directory locally and then we will give the path for the directory inside of the container. So when we do this, it will create the container exactly similar to that. And now if we go inside this, you can see right now this docker test directory is empty. But let's do one more thing. The ID is C4, so I can say docker execute C4 apt get update. So let's do this one, which will be very quick, and it's done. Now apt get install nginx with a y flag. After this, you will be able to see we will have that index debian file inside of this docker test, and right now it's appeared. This is why this has happened, because we have connected the volume. So whatever happening inside of the var www.html directory, everything happened inside this docker test. So the folder var www.html folder inside of the docker container is exactly same as the docker test directory. So we have linked it. So this means if I run this nginx, so I'll say start and I'll say service nginx start, which is I need to remove this apt-get, and once again this index or the HTML for nginx is available. But now I want to update it, since I cannot update directly on inside of the container, but I can update this index file. So let's open this file with VS Code, or so VS Code is here, and inside this I'm going to change this to welcome to Bitfumes. As soon as I save it, I don't have to do anything, and you can see it's running and it's using the file which I have. So this is the way we can connect the volume, and you can add the project directory locally to the directory wherever you want inside of the nginx. So if you don't want to use this, let's just quit it. If you don't want to use this one, you can totally remove it and it will say, hey, not found. Yep, that's okay. I'm going to create, so cd into this directory, and I'm going to create a new file called index, and here I will say h1 hello bitfumes and closing this h1, and that's done. And since we have created that file inside this docker test directory, which is mapped or linked to the var www.html directory of container, that Nginx will pick that file, and here you can see hello bitfumes is there for this index.html file. So this is the way we can actually connect the volume of container and the local. So let's see, this container is having all these things, and now we can simply stop this one or kill it. If you don't want to use, then just kill it directly and docker remove c4, and that's done. So let's move to the next big thing in Docker. For the couple of videos, what we are doing, we are creating the container via Ubuntu image. Then we do the apt-get update, the Nginx install, and the Nginx starting. Every time we need to do, we do via docker execute command. But is there any way we can reduce these steps? Yes, there is a way. So introducing you with a Dockerfile. Now, what is a Dockerfile? As the name suggests, is a Docker file where you define the steps to create your own image. Yes, I told you image can be created from another image. So yes, we are going to use a Ubuntu image. Over that, we do some installation like apt-get upgrade, Nginx installing, and then we will see how we can start the Nginx in the background and keep the container running always. Let's do everything in this episode. The very first thing I want to do is create a Docker file. So let's say touch Dockerfile, and it could be Dockerfile. No, you have to be very specific. The Docker file should start with a capital D and everything else will be as a small case. So you need to create a Docker file like this, but make sure you are on a proper directory where you want to create. So I am on my Docker test directory, and here if I create the Docker file, it's now available here. So if I open, okay, I think it's already open. Let me zoom out first and check. Yes. So here now we have this Docker file. So let's write something inside this Docker file. So I'm going to use Vim and use the Docker file. And here we know this is an empty file. So first thing I want to say, like, I want to create an image. As I told you, Docker file is to create an image. Now, I also told you that image can be created from other image. So I'm going to use a Ubuntu image. So first thing I need to tell is, hey, I want to use an image of Ubuntu, and to tell this thing, I need to say from. So from Ubuntu, how I'm writing it right. If you really want to give any tag or version, you can define something like this, or you can say latest. But if you're not providing anything, it will going to take the latest one. Okay, so this is fine. So I said that, okay, take the Ubuntu image and then run something on it or execute some command. What command? I want to say first apt-get update. This is the first command I want to run. So if I want to run, I need to use this run thing. So first I said from, which is always in capital, from Ubuntu image, run apt-get update. After this, I want to say once again run, and this time apt-get install Nginx with a -y, and this is the normal thing. Okay, so first I'm going to quit from this Vim by pressing escape :WQ, write and quit. See this, W and Q, write and quit. Okay, so if this is done, then we can see the Docker file is having these data. So remember, we have this Docker commands where we have this Docker build command. Build image from Dockerfile. And yes, we already have the Dockerfile here. So we are going to use this Dockerfile. How we can do that? We can say Docker build and provide the path or directory for the Dockerfile. Since I am already on that directory where I have the Dockerfile, I don't have to say anything. So I just say docker build dot. Dot is just to tell to the Docker that, hey, use the current directory and find the Dockerfile, because the name always going to be the Dockerfile with a capital D. Now let's see if I hit enter, what's going to happen. So there are something happening. It says building, which is now finished, but internal loading definition from Dockerfile, all the thing which we want is loaded, and then started from three things we did, which is Ubuntu, from, then to kind of run. I can do this thing. So there are three steps, first, second, and third. So that's why it says first from Docker Ubuntu. This is the one which is from Docker Hub. Then it says that, okay, apt-get update, apt-get install Nginx, and then this image is ready. And you can see this image having a this ID, and which is a very long hash, and we can check on the Docker images that do we have the ID, do we have the image, not the ID. Yeah, so we have this image, but you can see, yes, we have this image with the ID, but there is no tag and there is no repository, or simply there is no name for the image. We can use the same Dockerfile to build anytime, to build how many Docker images you want. So I'm going to build another image, but this time I'm going to give a T flag which is going to tag it. So I say Nginx Ubuntu because I have installed the Nginx, and then I will use a colon and I will say 1.0. This is the version or the tag I have given, and let's hit enter. So once again it's doing all these things, and this time you can see the naming to Dockerfile Nginx Ubuntu 1.0. Cool. Let's again see the image, and this time we have the same image but with the different name and the tag. So isn't it really amazing? What if I once again say with Ubuntu 2, like Nginx Ubuntu 2 and then if I check for images, now I have two image, but you can see the image ID is exactly same. So what Docker did is it used same you can say file, and it has created exact same image but with a different name. Okay, because everything is cached here, so that's why it is having exactly same. Now I'm going to remove Docker remove image, and I can say OC3, but if I use this ID it's going to remove both of them. So I'm going to use the name, so remove images, and no such image. Oh really? So maybe I need to use the OC. Let's say OC. Okay, now it says unable to delete image multiple repository. Okay, there is a conflict, so that's why I can use image delete with a force command. This is going to actually remove the images. Now we are back with no image. Let's create the image by using Docker build, and we now only have a single image. Cool. This is done. So image is created from the Dockerfile. Let's create the container. Docker run, and we know we have given the flag of what was the flag? Simply not the flag, actually the name, which is Nginx Ubuntu, and we are running it. But we know to run we can use the interactive and TTY flag, and I want to start bash as soon as the container is running. So run it, and now it says can't find the image locally. So maybe I can check for image name exact. Okay, so it's 2 actually. So -2, and now it's again saying this. So maybe I can paste it instead of doing that. Still it says Ugh, that's not good. So I'm going to use the id docker run this image, and yep, you can see the container is up. So I can open the new terminal, and then I can say docker ps a, and here you can see this image is used to create this container. The command we have is bash. It's up for 8 seconds, and now we can check for Nginx version, and I think Nginx -v only, and yes, you can see Nginx is already installed. Okay, that's really great. But let's again go to the Dockerfile. So we have given these two commands. So when this command is going to run, this command will run when you create the image. So image will already going to have this apt-get update and apt-get install of Nginx. But is it going to really work? Let's exit from here, and then I'm going to remove the container we have. So let's get the container name or ID. Actually, this is the ID. I will give it, and now I should have no container. That's good. But this time I'm going to run the same image to create the container, but I want to give the port of 9001 with the 80 port inside of the container, and everything is good. So let's go. We are inside the bash, and let's try. Do we have? Okay, 9000 is not working. So let's see how we can actually run the Nginx from this Dockerfile and not doing anything, just using the Dockerfile. Let's see in the next episode. In the last episode, we have created a image from Dockerfile, and that image we used to create the container. So if I say docker images, we have this Nginx Ubuntu -2. This is just the name, but let's use this one once again to create the container. But this time we have used this image to actually start the bash. But if we do this, we can see we have the Nginx, but it's not yet started, and that's why you can see 9001 is not working. So what I have to do, I just need to say Nginx, or maybe you can say service is Nginx start. Both of this will going to start the Nginx. But if you exit from here, we will lose the Nginx. Why? Because at this time, if I see all the containers, container status is exited. It's not running. So how we can actually run the Nginx, and actually why we need to go inside the bash? We have the Dockerfile. So if I open the Dockerfile, yes, we have this run. Can we also do this like run Nginx? But remember, I told you that this run command will only going to work when you build an image, not for the container. We need to run this when the container is running, not for the image. So we cannot use run. So what we can use the cmd command. So the difference between run and the cmd is very simple. Run is going to run when you build the image, but cmd will going to run when you create the container using the same image. Okay, and I just want to make it uppercased, nothing else. Okay, now I just want to run Nginx. So I can say inside the double bracket that, hey, I want to run the Nginx. Cool. Okay, so I just quit and save like this, escape :wq, quit and save. It's done. And now once again say docker build, and this time I'm going to give a image name as Nginx Ubuntu, and this should work. So you can see it has only ran 3 things, not the 4. Fourth one is cmd, which is going to run when you create the container. So let's use the docker run command, and I'm going to use the image which has just created, which is having the hash id of this one start with fc8. So I can just use fc, a short form, and try to run it. You can see it's running, but do we have Nginx running? No. Why? Because if I exit and if I check for container, it exited. So that's not a good thing. So what we can do, so first I'm going to remove all the containers once again, and also I'm going to remove all the images using this command. And I'm going to do one thing. I will open the Dockerfile and then I will say, hey, you just not need to run the Nginx, but you need to run in a background as a daemon. So I just need to say, hey, I have a global flag. Also, I want to use it as a daemon off. Okay, so it's not going to be on the background. It will always going to run. So when you run the Nginx manually, even if you are not opening the terminal, it will continue run. That's a daemon thing. But we will say daemon off. That means it will stay open inside the container, and that will keep the container alive. So yes, we are closing the daemon, we are making it off so that Nginx terminal will always going to be opened, so that container will always stay alive. That's good. So remember, I have used the comma and double quotes, and I just need to say quit and save. Docker build, same thing. This one is the image which I want to create. Image is created, and I will say docker run. This time the image ID start with the A6. So A6, run it. Oops, I did the bash. This is not good. When you define the command you want to run, then the container will use this command instead of the command you have defined in the Dockerfile. So this command will not going to be used if you have already defined it. So I'm going to exit it and I'm going to run once again. It will create another container, but without any command. So at this time it should create, and you can see it is still active. And on the next terminal, if I check for docker ps, you can see one container is exited, which used bash. Another container is active, or it's alive, because it has Nginx daemon off. By doing that, we should get 9000 running. And yes, you can see 9001 is running right here right now. But here we can see it is still taking this terminal. It is not running in the background, and we know how we can do this. If I press Ctrl C, this is going to stop the container, I believe. Yep, the container is stopped. So I'm going to remove the containers. So once again, it has removed the image also. That's by default. So I say docker build once again. It's building. It will be quick. But this time when I say docker run, and I need to use the image. So first I need to get the image A6 once again, same. I need to run docker run, and this time I'm going to say detached flag. So detached flag, it has given the ID, and this is going to work for sure. Right, you can see 9001 is there. And if I say docker ps, yes, this is up always. So if you want to stop this one, you need to say docker stop. The container name is 37 with the ID, and it has stopped. That means we will not going to get the Nginx. Okay, so I think you got the point, like how and why we create the Docker file, and by doing that we can do any sort of things we really want. You can define a lot of things here which you don't want to do manually. This will going to run always when you create the image. This is really great, amazing. So let's move to the next thing in Docker. Till now we have created the containers, we have created the images, and also used the Docker file. Now is the time to move to the major things like connecting the volume That's not the thing we have already done. By creating the Docker volume and creating the network using multiple container and connecting them in single application, and finally we will use the Docker Compose to create everything in one go. Let's start from creating the Docker volume. So I will open the terminal as usual, and here I actually need to open the terminal here, right here. Now first I will say Docker volume and get the help. Whatever you want to do, if you are using that command first time, always try to get the help. So this command Docker volume is manage your volumes inside of the Docker. So there are commands like create, inspect, ls, which is list, prune, unused, removing unused volumes, and removing any volume. So let's first see, do we really have any volume? So I will say ls. Now we have lot of volumes and we don't know if volume is in use or not. So what we can do, we can say Docker volume prune. Now prune will going to remove any volume which is not in used. So if I run it, it's asking for confirmation and it has removed a lot of volumes. So once again, if I do ls, you can see now I don't have any volume. So how we can create a volume? As we know, we have a command called create. Now obviously you need to give a name. So I will say demo volume, so vol for volume, hit enter, and this demo volume is created. Now let's once again do the ls, and yes, we have this demo volume and the driver is local. Okay, but we also have another command called Docker volume, and let's get the help, which is called inspect, and inspect the detail of the volume. So inspect, let's say inspecting demo volume, and now we get the information about the volume. So why we are creating this volume? This volume is created by the Docker command. That means Docker is managing where it is, what is the scope, and what is the driver, every other thing. So the real important thing is mount point. Mount point is inside var, lib, Docker, volume, demo volume, and under data. So whenever you create any volume using the Docker, you have this directory which is going to linked with your application. And now what is the difference between this volume and when we create a Docker file, Docker run it with a p flag? Let's find out anywhere we have used a volume. So it's going to be long one. So I think here somewhere, yeah. So here we had used this path to define the local volume or local directory. Now with this command, with the -v, yes, we can define our own directory path, but when we create a volume, then what's going to happen, we just define this volume name and we don't have to worry about the directory. And this is why this volume is absolutely useful. Now let's use the same command. I will copy it, and instead of this long thing, I'm going to do it in a different way. So I say Docker run itd, but I will use this backslash, or if you are on Windows you can use backticks, and this will create a new line which is going to be very nice. Now I will define the port 900180, And once again I will say -v, and this time I will say demo wall, and then I will define, okay, sorry, I did it wrong. So what I have to do, we need to define the internal container directory. So let's connect with the var. So this volume is going to connect it with the var. Okay, so this is done, and after that we can say that, okay, so interactive, I'm not using the d flag. D flag is going to move in the detached mode, but I really want to have it. So then I will say ubuntu bash. Okay, so let's run it, and it says we already have the container, so I'm going to remove each and every container we all have, run it, and yes, we are here. Now what's going to happen if I go cd var and do the ll, we can see we have a lot of things. Now let's go into once again I say docker volume inspect demo, and this is the real path where the Docker has created the volume. So I go inside it, no such directory, I cannot go inside it. So what we can do, yeah, what we can do, this is really important question. So we can say create an index.html file. We don't have the vim, so we can say touch let's say index.txt, index, not index, and then I say echo hello world inside of index.html, and then if I say cat index.html, we have the hello world. Now what's going to happen, let's exit from this container. I exited from this container, and now if I say docker ps, we have this container. I'm going to remove this container, removing 2.5. That's good. Now we don't have any container. Let's create the container once again using the same command, and this time you can see I have this volume again, the same volume I'm connecting with the new container, and it's a new container, so it should not have that index.txt file. Now let's create it. Let's go inside cd var, and you can see we have this index.txt. How that possible? Because this is a new instance of container. This happened because we have connected the volume, and volume persist. Volume is there, and we cannot directly go inside that volume. It's a secured one, but if we see here, it's having all the things inside the volume on the connected directory. So this is the real way you can have your volume inside of the Docker, and that's really useful thing. Okay, so in the next episode we will move and see how we can create something else inside the Docker. Okay, just like we know about the volumes, there is another concept of network. So Docker network is absolutely useful in connecting multiple containers. So how we can learn about it? In the last episode of the volume, I told you, like, if you really want to understand about any command, then you just need to write it docker and let's say network, and then get the help. Yes, this is saying that you can use this command to manage the networks, and there are some commands related like connect, create, disconnect, inspect, ls, prune, and remove. Okay, so we have this ls command. Let's start with this one. So I say docker network ls. This says that you have a 4 network, and among that we can see we have this test net, which I have created before starting this video. But we know that there is a prune command. So docker network prune, and what this prune will do, prune will going to remove any network which is not in use. Okay, so if I do this, it's first confirming, and I say yes, and it has deleted only the test net. Why not these 3? Because these 3 are in use, and they are actually used by Docker itself, so you cannot remove them. Okay, so this means if I do the ls once again, we can see the test net is not available. So how we can create a network? So docker network create, the command create, and testnet is there. But let's see, yes, we have this testnet. But if you really want to remove any network manually, whether it is running or not, you can say docker network rm for remove, get the id, and boom, it's removed. And this means the testnet should not be available right here. Cool. So we can create the network something like this. We have the network, and what else? The point is how we can use this network and what is the use of this network. Okay, so for this, let me take you to the Docker documentation. Here on the developer section, you can go to the documentation. Maybe you can also go to the reference. Inside the reference, you have a command line reference, and then for the Docker CLI. Inside that, if you scroll down, you will find Docker network command. So yeah, this one. And inside that, we have a lot of command. So we have seen like ls, which is going to list all our networks, something like this. Okay, so you can also say like no truncate, that means you cannot remove them like that. So you can filter by the drivers, you can do a lot of other things. Then we have seen how we can create a network. So we can use the create network like this. You can define the driver by having the d flag, but the driver, which is, if we see, like there is one more command, so I can show you like this one and say docker network inspect, and inspecting this one 40. You can see this inspect command will give you all the information, and here it says that driver is bridge. The bridge driver is the default driver for any network if you have not defined it. But if you really want to define any other driver, you can use the -d flag. Okay, so that's a normal thing you can do. We have seen prune, we have seen remove, but the important one, we have just seen the inspect, but the important one is connect. So when you have created a network, you can connect any container inside that network. Okay, so what is the use of that network? First, let's understand this. When you have created a container for MySQL, you have created another container for Nginx or your application. Now, application want to access the MySQL, but we know that container are isolated things. They cannot interact with each other. So we have to create a network. Via that network, both of the container will going to interact. But to connect that network, we need to do something. So here it says that you just need to say docker network connect and some connections. So how it's going to work? It's going to work something like this. You have a container name, you have a network name, and that's going to work. So docker run and something like ID flag, and you can define the network here when you want to create network directly. So let's see how this is going to work. First, let me show you how you can by default create container with a network. So first, we can see we have a network called testnet, and then I will say docker run with the I and T flag for Ubuntu, and I want to open the bash. But let's connect this with network. So I will say network. When I have used the double hyphen, I need to say equal to sign and the name of the network. It's a test net. Now if I run it, it's working. That's really cool. But if you go here and say ps all, yeah, this is the network, but let's inspect this. So docker inspect 52, and this time you can see on the network section for the inspect or details of the container, if you scroll down, you have a network, and the network is this test net, and this is really we need. So we have one container for Ubuntu. We can create another container for the MySQL, and then if we want to connect both of these things in a single application but different containers, we will use the network. So we get the concept of how we can create the network, what contain network is, and how we can connect with the container. So we need to really work with a real application. But let's first understand, what if we have created a container without any network, and then I want to add that container which is having no network to our existing network. So first let's say docker remove all the containers. Docker remove all containers. Now I don't have any container, so let's create a new container. This time I will say, okay, this is a container name. Let's first say docker. This is up because we have this running. And now using this container, I'm going to connect this container with the network we already have. But first let's see docker inspect 19. You can see the network is the default one, which is the bridge network. It's not our network, it's a default network which is bridge one. But now I want to say docker connect, and how we can connect it. So it says docker network connect, the network name and the container name. So first I need to say network connect, first the network name testnet, then the container name, which I can use the ID, which is the just 2 letter if you don't have a lot of containers, and that's done. This means this time if I go and inspect the container along with the bridge container, it's also connected with the testnet container. So now we have a 2 network, not container. So along with the bridge network, the container is connected with the testnet network. So it's a 2 network for a single container. And if you want to disconnect it, so same command but with a disconnect command. Okay, and this time just bridge, and you can see there is no other network available. Okay, so this is how we create the container, we connect the container and disconnect the container. But we want to really work with a real application. How we can do that? We will follow the documentation of the Docker. See you in the next episode. I want to work with a real application where we can start the server, we can connect with the database, and we have some volume connected, porting, port sharing, and everything we have learned so far. How we can do that? We are not going to work on any bigger application. We just want a very simple application which will be available here on the documentation. So go to the docker.com. On this developer section we have this docs. So go to the docs, and here you will find this getting started. On the getting started you will find this part, get started, which is very important, and click on the part 2 called sample application. Now on the sample application it says that you have to download this node application, but don't worry about this. If you are not aware of node, it's not going to happen. We are not going to touch any node related things, but for now I'm going to open this in a new tab, and this is the one, but we have to actually clone full repository, and then we will go inside this app directory and we will copy each and everything. So this is the mini project they have given us. So let's go here, copy it, and here I'm going to say hey git clone and this thing, and I'm going to give a demo project name. So this is going to clone this repository in our system. So it's done, and now I can close it, and you can see inside the Docker we have a demo project. This is the demo project. Inside the demo project we have a lot of things, but we are interested in this app directory. So I will open the terminal for this app directory, and this terminal I'll just say code and dot. That means I'm going to open this only the app directory with our VS Code. Okay, so let's close this terminal because now I will work on this project. So first if I open this package.json, this is actually going to use the node version of 12. Okay, so the node version currently we have is 17, the stable one. So how we can get the node version 12? We cannot do that, although we can use the nvm, but this is a Docker tutorial, so let's do everything with the Docker. So I know I have Docker, and if I go to the Docker hub, so hub.docker, and let's search for node image. I'm going to search for node image, and we can pull out, but we can pull out any version here. So if I click on any version here, you can get the version easily by defining the version number after the image name. So we want to pull, or we want to run the node, but version 12. That's very important. So let's run this with the interactive flag and tty. So this is going to be available. Since this node 12 is not available locally, it's going to download from the Docker hub, and we have lots of layers of the image, so it's going to download each and everything one by one. Let's wait for this to complete. So we can see it's a very big image. I don't want to use this big image, so I can just press Ctrl C and Ctrl D, and then instead of just 12, I will say I want to use the Alpine. So 12 Alpine is a smaller image which is easily downloaded, and it will not take a lot of space, and it has only the essential thing which we need. So some of the things were already created, already downloaded, and now we have the Alpine, and it says that welcome to node version 12. So now we have the container and we have the image for node version. Now if I check Docker ps with a flag, you can see we have this node 12 Alpine, which is really good, and this is the container actually with this image. Okay, so this one is up and running, and what we can do, we have to define, and I can press Ctrl C. Let's see what we have to do next. It says that once you have done with this, then you need to create a Docker file with all these things. So let's just copy this, and on the root of this project, I'm going to create a Dockerfile, and we know what Dockerfile is. Dockerfile is to create an image with some additional thing which we really want to do manually. So we are going to create an image out of another image, which is node 12 Alpine. Then we will add something like Python 2 G++, and this is the requirement for the project we are using. Once again, do not worry about what we are installing, just see how we can move from here, from Dockerfile to the Docker compose file, and connecting each and everything using network. Let's see. So working directory is this app, which is the current one. So it says that copy, then yarn install, and running the node with exposing 3000. Okay, now this is done, and we are done with this. It says the same folder as package.json. That's good. After that, we need to docker build, getting started, and dot. So what we are doing, we are building using this Docker file. We are naming it getting started, and we are saying that whatever you have here. Okay, so docker build with this inside this directory, and with a tag of getting started. Run it, and it's working, and very soon we will have that image. So it's downloading some of the things, then it's going to install and actually run this command, and then everything will be available on our system. So now you can see it's done, and finally it's running the yarn install production. And finally, after some time, after 91 seconds, this is done and the image is there. So if I say docker images, we have this getting started image. We can build a container with this image. So everything is given here. So now we need to start a container. So we will expose this 3000 port from container and from our local. So docker run with a detached flag with the p, that means port of 3000:3000, using this image of getting started. Let's run it, and this is done. So now if I check, you can see this is up and running using the getting started image, and now there is a container. This means if I go through the localhost 3000, you can see this is the real image project. That means the project we have, it's a little to-do list. So first item inside the to-do list, and it's done. And if I reload this, you can see it is still persisted even if I open it in a new incognito window. So how this is persisted? This is persisted inside of this MySQL. So if you go on static, not on static, somewhere it should be there. Okay, so these are the tests. Oh, I got it. The MySQL directory or MySQL file is created inside of the container, I think. And if I try to remove this E0 with the force flag because it's running, so now there is no container. This means this should not work. And if I rerun or recreate a new container, it should start with a fresh installation, or I can say fresh DB. So database is created inside of our container every time. So this means if for any reason we lose the container, our database is removed. This is not a good thing. So let's start with working on this thing from the next video. Using this Dockerfile, we have created this getting started image, which is having Node Alpine 12 and with all these supporting things to run this Node application, which is a simple to-do list. Now, with this, let's create a container which is going to start with localhost 3000, and now we have this to-do list. But the problem with this is, like, yes, everything is persisted inside the SQLite database, but what if we remove the container like this one with a force flag? You will see that it's not running, and if we recreate another container, we'll lose our data. So let's first see where the database is. So if you open this source, persistence and SQLite, so the location is, if we have not given, then it will be etc to-do list to-do.db. So every time we create a container, there is the fresh etc, that means etc to-dos, and to-do.db file is created. Now, how we can use something Docker related thing to persist this thing? We first see that how many volumes we have. So let's see, we have one volume called demo wall. If you are not aware of this demo wall, then you should watch the previous video. Now we can use this demo volume to connect to create the SQLite database when we are running. So with the port, this thing we want to connect with demo wall with etc/todos. So todos, is this correct? Yes. So etc todos directory will be mapped with this demo wall. Now let's see what's going to happen. It's first say, do we really have any other thing? Okay, let's try. Okay, now it's created and we have it. Let's reload. Yes, we have this, my first to do item. Yes, it is there. Now I'm going to kill this container. So docker remove 38 with a force flag. Now it is done. So docker remove each and every container. There is no container, that's okay. But once again I'm going to create another container. This is a fresh new container, so let's see what's going to happen. If I reload, and amazing, you can see the database is persisted here because the file is created inside of this demo wall, not inside the container for this directory. So this is really cool thing. You know, using SQLite database is okay, but I want to use MySQL database. How we can do this? So if you go inside this source directory, then we have persistence. If you go to the index, it says that if you have defined the MySQL underscore host environment variable, then it will going to use the MySQL. Otherwise it will going to use the SQLite. So when we ran the container, we have never defined any environment thing, so that's why we were using the SQLite, but we need to use the MySQL. So first let's see how we can have a MySQL image up and running and creating the database. For that, first I need to run or create a container for MySQL image. So very first thing I'm going to do is saying that docker run MySQL, but this time MySQL will be 5.7 only. So if I try to run it locally, it will going to first check for the local, it's not available, and on that it says that hey, you cannot use the normal image with your M1 chip. So what we have to do, define a platform flag, and here we can simply say AMD 64. So give me the AMD 64 version for the MySQL 5.7. okay, so it's still not working. Maybe I need to define it before this image name. So first remove it from here and then define something like this. Okay, so this is going to work, and yeah, it's pulling the image, and very soon we will have it. It's a big image, so I will going to pause this one, and then we will restart. So now we are done with this one. So image is there, container should be available. If I check, yes, container is there, and you can see it is exited. So we don't want to exit from the container because we want to create a database inside this MySQL. So once again, let's run this one, but with the interactive flag, so that we can see whatever we are whatever happening inside this container. So you can see it says database is uninitialized, password option not specified. So you need to first define this environment variable. Okay, so let's do that. Also I want to say that hey, I want to define the environment of MySQL root password, which is in our case I can give secret. Now hit enter and see what's happening next. And now since we have given the password, now all the things are happening. It's trying to start the MySQL server inside of the container. Okay, so once this is done, we can actually open a new terminal and check for a container, and this container is up with a 3D as the ID. So you can see it is there, and now let's try to execute one command inside 3D container. So the container ID is 3D. I'm running the MySQL with a user or root password. It's asking, and I'm giving the secret as the password, and I am inside the MySQL of the container, which is running in this tab. So let's see, show databases, and you can see we don't have any extra database. Obviously we have not created, but we can create a new database. But next thing I want to do is I just want to kill this terminal, so that I don't want this container to run. So if I check for containers, all the containers are Oh, this one is still working, still running. I think it's not yet stopped, so I can just remove this one. Now next what I will do, I will not only just define the environment for the root password, I will also define the environment for MySQL database. Okay, and here we will define to-dos. So this is the database name. This means when we initialize this one, once again it will not only just start the MySQL inside of the container, but it will also create a new database called to-dos. So once this is done, let's open a new terminal, check for container. 87 is the ID which is up and running. So container execute 87 MySQL root with the password of secret. We are here, show databases, and now you will see that we have a new database called to-dos. Cool. So we have once again check how actually we can create the container for MySQL. But the point is, once this is done, we have actually the database inside of the container. How we can create a container with the getting started image and use the MySQL. So I told you, if we go inside the persistence, if we have defined the MySQL host for the container of getting started, then it will going to find the MySQL, and we need to define some other things to really connect it. How? If we go inside the mysql.js, we need to define these things: the MySQL password and the MySQL host and MySQL user and MySQL host. All these things if we define, then we will easily able to connect it. So let's see how we can bridge the container for MySQL and container for Node through the network in the Docker. So this time we need to connect our to-do app, which is a Node image, with the MySQL image, and we are going to use the network thing to have the connection between the two container. So first let's create a network. So I will say docker network create, and this time I will say to-do net, the name I have given, nothing else. So docker network ls, we have a lot of, but we need to use to-do net. Now after this we need to create our MySQL image, but not only we just need to define the network, we also need to define the alias so that it will be easy to write the name of the connection we want to do. So instead of writing all these things, I can just copy from here and make sure if you are on Mac, then you can copy this one, not this one, because this is for the M1 chip if you are having it. So copy this one and paste it, and let's change some of the things for our need, because now we don't have the volume. So let's create a to-do volume, and the network is to-do net, which we have already created. So let's see if we have the volumes. So no, there is no volume. So docker volume create to-do vol, which we have used here. So everything is there. We have the network, we have given the alias, just another name to be easy to remember. We are using a detach flag, we are defining the platform, we are connecting the volume, we are providing the environment variable. Everything is set for MySQL. So run it, and now if you want to see what happening inside this container, we can say docker logs of E1, and now it's waiting for server startup, and finally temporary server started. So now docker ps, with this it says that MySQL is running. Cool. And also this MySQL is running with the network of to-do net with the alias of MySQL. Now everything is fine. What next we can do? We can now run our application, but on that, remember, we need to define all these things so that we can easily connect our application with the MySQL. So now I can once again run and Docker with this thing, but we also need to define the network, and we also need to define these environment variables. So this is going to be amazing. So Docker run, this time I should find yeah, so maybe I can find something like this, Docker, yeah, here we are. So we don't need the volume because now everything is connected on the container for MySQL. It's in the detach flag for port of 3000. Now I will say, hey, I also need to define the network. So network is to do net. After that, I want to say that, hey, the environment of these things. So I can just copy all these environments from here and paste it, something like this. So yes, MySQL is the alias given for the MySQL container network, and user is root, password is secret, database is to-dos. And finally, we need to say, instead of this thing, we already have an image called getting started. So getting started is the one. Now this one is running, and let's see if it is working. Yes, so app is working. What if I say my first item, and yes, it is there. I reload. This is not you can say removed. And now what I will do, first I will say docker ps, and since we have the container for MySQL, let's go inside the container and see something is happening or not. So I can say docker execute on 8.1. Is that 8.1? No, what's that? It's even. Okay, so I want to go inside it. Password is secret. I am inside the MySQL, and let's say show databases. We have the to-do database, so let's say select everything from to-dos. Oh, we need to first use to-dos, and then we can say, yeah, to-dos, select everything. Oh, show tables. It's not a table, it's a database. So show tables, and now we have a to-do items. So now I can say select everything from to-do items, and yes, we have my first item. Now what if I remove this one? So there is nothing. So once again, if I run it, it's deleted. So I say second item, and once again if I check, boom, it is there. So with this we are sure that the app we are using is actually working absolutely fine, and these two containers which we have given here for MySQL and the getting started image is now connected through the network. And the best part of these things is, suppose I'm going to remove both of these containers, boom, both container died. We are not having this image. Now see what's going to happen. First I will say docker run, and I will run the MySQL image first. Why? Because it takes little time to start. Okay, while this is running, I will say docker run, and I will start my app, my application, with the same network definition, and here is the new container, so it's connected. Is this going to have all the data? Because we have removed the container, even the MySQL container, but you can see this is there. Why? Because when we created the MySQL container, we have defined this volume. Volume is on our local machine, so it doesn't matter, whenever you start the container, it's always going to save the MySQL data locally, not inside the container. So at the last, yes, we are connecting two different containers. We are having a MySQL container which is just running the MySQL, but at last everything is detached, secured, separate, and safe. Cool. this is good, but remember, doing all these things multiple times, writing all these commands and flags and options is not good. In the next episode, we will learn about the Docker Compose and see how we can use the Docker Compose file to actually create the container. Since we have seen the Dockerfile, which is for images, now it's time to create a file for the container. See you in the next video. Just like we have a Docker file to create the Docker images, we also can create the container with predefined instructions. How? Using the Docker Compose file. So let's work about the Docker Compose, understand how we can write some instruction to create a container from given image. Cool. First, to have that, we first need to check, do we really have a Docker Compose in our application or not? So why we need this? Why we can not just create the container manually? So here we can see we have to create two different container with a lot of information, with the network, with the volumes. Lots of things are happening here. So it's very hard to do all these things manually again and again and again. So what we are going to do, we are going to put all these information in the Docker Compose file, and then we will just use that Docker Compose file to have everything in one go. So that's why we need to first check, do we have the Docker Compose or not? So first you need to say docker-compose and then version. No flag, no hyphen, no double hyphen. So if you have it, if you are getting this, then you are good to go. Otherwise, you need to install the Docker with this Docker Compose option also. Cool. So what you have to do, it says that first, let's create a file called dockercompose.yaml or YML. You can once again create this one at the root level. So yes, we have dockercompose.yml. The first ever thing is you need to define the version of this one. So what is this version? So Docker Compose file start by defining the schema version. It's not the Docker Compose version or even the Docker version. It's the schema version, like how, in which format I'm writing this instructions. So we will use the Docker schema version of 3.7, which is default. Don't worry about that. And then we can define the services. Services means what actually we want to do on the container level. So first, remember, we have done this thing, and that's why first thing is for the app. Remember the node app? Yes. For that, we have to create the node application first. Then we will work on the MySQL also. So now it says services, and services actually means container. So how many containers we need? We need two containers. One is app and another is for MySQL. I save it. It has auto formatted the VS Code. Next, what we need the volume so that our MySQL data will be persisted. So we can say I need a volumes. So like here. And what is the name of the volume? Our volume name is going to be a to-do vol. Do we need any instruction for this? No. If we can define some like driver, then you can define it. Otherwise, leave it as it is. What else we need? Yes, we need a network also. But you know, when you create the container using this Docker Compose file, Docker Compose will automatically create a network for you. This means all the containers, all the services here will be in a single network. So that's cool. Now, first, we need to define what we need for the app, the container called app. So let's open the terminal and see what we need. First, we need where we can get the image. So yes, you can use the getting started image, but since we are using this Docker Compose file, we don't need this Dockerfile, which is just to create the image. We can do all of these things in our Docker Compose file. Okay, so let's first define what we need. We need the image. And what image we need? We need the image called node 12 alpine. Okay, so node 12 alpine with a space. Now what next we need? See, it says that you need to define the environment variables, all of these things. So now I say environment. Okay, now after that we need to give one more indentation and then paste it. And obviously we need to remove all these things just like it, and we need to use the colon with a space. Okay, so everything is done. I can do some space with like here. So now we have defined the environment variables, and I think these are 2 indented, only 1 indentation is required, and when we save it, it auto format, by the way. So what next we need? We need the network, and we don't have to define the network. Then comes the port. So here we need to define the ports, and we can define multiple port, that's why it's a ports. And when we need to provide the list, then we can say hyphen and whatever you want to give. So I will to say 3000:3000. Once again save it, it has auto formatted. So port is done, network is automatically created, environments are also done. For the image, we have just defined the image, but there are more things in Dockerfile. It says that you need to run this command first. Okay, so let's have this command. So we can define the command we need. So we need to say, hey command, like here. So yes, we need to say that it is going to be a shell command with a -c flag, and inside this double quote I will say, hey, run all these things, and after that just install the yarn, or you can use the npm also. Then that means double and sign, I say yarn run dev. So it's going to be a development environment. Okay, now let's run this one and see how it's going to work. So first you will see, do we have anything? Yes, we have a container, so I'm going to remove all the containers. That's good. I'm going to remove all the images if we have. Cool. Now I will say docker compose, and I will use the up command. And since we are on the same directory where we are working, where we have the Dockerfile, we can just say docker compose up. And now it will pulling alpine 12 for the node alpine 12 image, and then it's going to create the container. Then it's installing, the running this script and doing all the things we need. And finally it has exited because it says that couldn't find the package.json. It says that, hey, you are trying to install the yarn, but I can't find this package.json. This means we need to tell to our container that what is our working directory. So working dir is going to be simple /app, or you can say like site, whatever you want to give, but you have to be specific, because after that we need to connect the volume. Why? Because we need to say that, hey, use this image. If you don't want, you cannot. If you are not defining working directory, that's going to be okay, but I will say, hey, the volume is going to be like here, and I need to say it's going to be inside the same directory where I'm working this docker compose file, and map this with the app directory. And that's why we need to have the working directory here. So I can say working directory, and it's volumes and .:app. So by doing all these things, we are saying to the container that, hey container, you need to run every command inside this app directory on the container, and this app directory is actually connected with the local directory of where I am running this compose command. So once again, let's do the docker compose. It says, hey, cannot create container with a service called app. Something is invalid mount. So first let's remove if we have anything. Okay, container is removed. and it's having some issue. So we are getting this error because we have defined that slash app and we have forgot to define the slash here. Everything is good. Now this is going to start our container with all of these information we have given, which is a combination of Dockerfile data, the Dockerfile data with the container instructions we have. So now it says that address MySQL not found, because of some reason it says that, hey, where is the MySQL? Now let's go in the next episode and see how we can create the container for MySQL using this Docker up. So let's move to the next video. So just like we have defined everything for the app container, let's do the same thing for the MySQL container. So I'm going to say, hey, I need to create a container called MySQL, where I'm going to use the image called MySQL 5.7. But remember, we need to do a lot of other things. So let's just kill it, and I will remove each and every container, and then I will say Docker run for this MySQL image. And very important thing is these environment variables. So I need these two environment variables, put it here, and I need to use this, something like this, and it's colon here also, and like here with a space. Cool. So environment is done. Then the volume, which is very important. Now we are creating this to do vol. So let's connect the volume. So I will say, hey, volumes is going to be obviously to do vol with the var lib MySQL. Okay, that's also done. So it should be only one indentation. Okay, so that's a formatting thing, no issue. Volume is also done, and important thing is platform. We need to define the platform also. So after this, let's have the platform and colon platform. Everything is done, but network, I said Docker Compose already create network when you create container with this thing. So in the last episode, when we said Docker Compose up, it was giving error for this container because at that time the host MySQL was not there. But when you create this containers and this name should match with this name, then it will find it. So it says that, hey, the network it's going to create, and it will by default give the alias of MySQL, which we did like this. Okay, so everything is done, and we have two container, one volume, and let's check for volume. Do we have the volume? ls, yeah, so we have the volume. I'm going to prune all the volume. Good. Do we have the network? Let's just prune each and every network if we have it or not. Now we don't have any volume, we don't have any unused network, we don't have any containers, and we have some image which is only Alpine image. Now it's time for the real magic. So Docker Compose up. When we say Docker Compose up, it's pulling just for the MySQL, because it is fresh one and it's going to take some time. So let's just wait for this to complete. And finally, you can see every MySQL thing is done, and then we have the app running with localhost 3000 inside the container, and some of other MySQL thing, and finally listening to the port 3000. This means if I go to the localhost, reload it, app is there, and we can say my Docker Compose with the compose. Yes, it is there, and that's cool. And the best part of the compose is you can see we have the volume by default created app underscore to do volume. Good. Now check for network. By default it has given the name app underscore default, the network name. If we see the containers, and container is there. Now what happened if we try to kill this? We can press Ctrl C, and very soon it says that stopping these two containers only. It's not removing the network, it's not removing the volume. So if we check the network is still there. If we check the volume is still there. But if you check for container are stopped, not removed, stopped. Okay, so that's done. So I will say once again, remove all the containers. We are keeping the volumes and network. Let's see what's going to happen. But this time when we say compose up, docker compose up, I will use the detach flag, which is just going to tell me that hey, something is happening, but everything happen on the background. We don't have to keep the terminal running. This means if we see the containers are there, let's check for volume. Here it's using the default volume, the volume which previously we were using, which is very nice. And for the network, it has also used the same network. It has not recreated the network, so that's good. So volumes and networks and containers, everything is up. If we reload it, yes, you can see the same application with the same database is still there, but we can play around with the container. We have to just define everything here. Okay, so this is the Docker compose, and at this point we are done with the basics of the Docker. So finally we are done with our Docker course, and it has covered all the basic things which you need to get started with the Docker. Now there are a lot of other things related to Docker. You can play around with every other thing, but everything need these basics knowledge. So this documentation is really amazing. It's open, free for you. You can reach to me for any issue, and then if you need any other crash course or full course or any type of course, anything you want to learn, just comment below. And if you like these videos, please give it a thumbs up, share this video with your developer friends, and don't forget to like Bitfumes on Facebook, Twitter, Instagram and LinkedIn. We will meet in some other videos. Till then, goodbye.